Okay, so this is chapter 12, homework problem number 1. This is going to be the payback period problem. So here we go. We've got the Volt company is considering investing in a wind turbine to generate its own power. It says any unused power will be sold back to the local utility company. Between cost savings and new revenues, here we go. The company expects to generate, here we're going to underline this, $760,000 per year in net cash inflow. So that's a plus $760,000. Now the cost of this thing is right here. It says the turbine would cost $4 million and is expected to have a 20-year useful life with no residual value. The problem says calculate the payback period. So for this type of problem, because this 760,000 bucks is an equal amount each year, it's the same amount each year, all you have to do is divide the investment by that cash flow. So down here you've got the initial investment, which is $4 million. You're going to divide that by your, again, $760,000. That's the equal amount that you're saving each year, or the positive cash inflow, and that's going to give you right about 5.26 years. Now this problem would be differently calculated a little bit is if this amount was unequal. Sometimes you get that, but for this one, whenever you have an equal inflow, all you have to do is divide the investment by the inflow to get the payback period. All right, so this is chapter 12 homework problem number 2. This is going to be pretty much the same type of problem, but this is going to be the accounting rate of return known as ARR. So again, we've got the windmill company is considered investing in a wind turbine to generate its own power. It says any unused power will be sold back to the local utility company. Between cost savings and new revenues, here's the numbers. The company expects to generate $763,250 per year in net cash inflows from the turbine. Okay, the turbine would cost $4.3 million, and we've got a 20-year life, and is expected to have a 20-year useful life with no residual value. Calculate the accounting rate of return. So if you go back to look at the PowerPoint that I illustrated for you, one of the ways to calculate this, the ARR, is to take your cash flows. I'm going to write this right here to remind you. Subtract out your depreciation expense, and then divide that by your investment, and that'll give you your ARR. So to calculate your depreciation expense, you have your total cost of investment, which is $4.3 million, $4,300,000. What you do is you just divide that by 20, since there's no residual value. And what that's going to do is that's going to give you annual depreciation expense right at $215,000. So what you do then is you take that cash flows, which is $763,250. You're going to subtract out that depreciation, because remember depreciation is non-cash, and then you're going to divide that by the $4,300,000. So as you can see up here, you can see the numbers. Here's where they get the average income from the asset. That's that numerator. You've got your investment in the denominator, and that's going to give you an accounting rate of return right at 12.75%. All right, this is chapter 12, homework problem number 3. You're going to be calculating the net present value. So I went ahead and already highlighted one of these icons. I chose the present value of annuity of $1. So that's basically this first tab right here. But let's go back and read the problem. We've got the Baker Company is considering investing in a wind turbine. It says any unused power will be sold back to the local utility company. So again, this is kind of like the same setup as the previous two problems, except they're just going to change the data a little bit. So it says between cost savings and new revenues, the company expects to generate, here we go, $897,000 per year in net cash inflows. It says the turbine would cost $4.6 million and is expected to have a 20-year useful life. Calculate the net present value using a 5% hurdle rate. That's going to be our interest rate. So again, the basic setup here is, I'm going to draw you a little picture. So we've got year 0, which is right now. So in terms of the cash, so if they make an investment right now of cash, that's going to be a negative $4,600,000. That's a cash outflow. I'm just going to put a negative there just to remind you that that's a cash outflow. Now basically for the next 20 years, I'm not going to write them all out, but for the next 20 years, they will generate a positive cash flow. I'm going to put a plus here, a positive cash flow of $897,000. Now, because that's going to be an equal amount, that's referred to as basic. I'm going to write this right here as an annuity. So what you're going to do is, because these are future dollar amounts, you want to tie everything back to today. What's happening today? So again, if you make the $4.6 million investment today, that is today's value. But if you look from 1 year from today, or 2 years, or 20 years from today, we have to make basically an apple to apple comparison. So using the concept of time value money, we take this 897, and because that's a future dollar amount, a future savings, we need to convert that back to today's dollars. So we go to this present value of annuity of $1. And so what you do is, I'm going to write this up here. The time period here, N is equal to 20 years, and I, which is our interest rate, is 5%. So using the table, I locate the 5%, and then I find the number of periods, which is 20. And where this intersects is this number right here. This is our present value table, which is 12.462. So we're going to multiply this number, this table factor, by our $897,000 cash flow. That's going to convert all those payments, all those cash flows, into today's dollars, and then we're going to net it with our initial cash outflow. So again, years 1 through 20, those represent cash inflows, whereas year 0 right now, that represents a cash outflow. So to calculate the net present value is you net the two. You net the inflows with the cash outflows, and hopefully you get a positive number. So when we take that 897, I'm going to go now and clear this. So when we take the 897,000 and multiply this by your table factor of 12.462, all right, here's the number it's going to give you. That's $11,178,414. So that's your present value of your cash inflows, and of course the present value of your outflows, which is today's dollars already, which I said is a negative $4,600,000, because that is today's dollars. So if you just net those two, that's going to give you your net present value, and that'll be right at $6,578,414. And notice it is a positive because our outflows are more than our inflows, and that's called your net present value. All right, this is chapter 12, homework problem number 4. You're going to be calculating the IRR, known as the internal rate of return. So again, same setup. We've got the windmill company is considering investing in a wind turbine to generate its own power. Any unused power will be sold back to the local utility company. Between cost savings and new revenues, the company expects to generate, and then they change the number again. This one is going to be $1,584,000 per year in net cash inflows, and it says the turbine would cost $4.8 million and has a 5-year useful life with no residual value. So with this particular problem with internal rate of return, the way you do the basic calculation is you take your initial investment. I'm going to write this right here just to remind you. Your initial investment, and you're going to divide that by your cash flows. Now, for this problem, our cash flows are the same amount each year. That $1,584,000, again, that's going to be our denominator. So write that right there. And our investment was $4,800,000. So the way this would work is you divide your investment by your cash flows, and because it's an annuity, you just divide this by the $1,584,000, and that's going to give us our internal rate of return number, or that's going to be like an index number. That's going to give us right around 3.0303. Again, it keeps going. So because this is a trial and error process, what you do is you have to pick the right table. Well, because it's an annuity and it's the same amount each year for 5 years, we're going to go to our present value of annuity table. I went ahead and clicked that. That's right here. And so the key here is it's a 5-year useful life. So if I go to the row where it says periods of 5, I'm trying to find this number, 3.0303. I'm trying to find what is that number in this table. So as I start to look, and I look and look, I get down to the right last part of the last two numbers here. I come up to 3.127 and 2.991. I know that my factor number, my IRR number, is going to be between these two numbers. Okay, so what that tells me then is my internal rate of return will be between 18 and 20%. And you'll notice that is the correct answer. So because this is a trial and error process, we know it's somewhere between 18 and 20%. That's all you have to say. But this is how you would do this particular problem with IRR. Is again, you take the investment, divide by your cash flows. Because it's an annuity, you can do it like this. Just divide by one number. That gives you your, this is the table factor you're trying to find. It's a 5-year life, so you go to the periods where it says 5, and you're simply trying to locate where does this number fall in the table. And most of the time, you're not going to get an exact number. You just have to come up with an estimate. And in this case, we're saying that our factor number is between 3.127 and 2.991. So we can just say then that our IRR is approximately between 18 and 20%. Okay, so this is chapter 12, homework problem number 5. We've got Monterey is considering investing in solar paneling for the roof of its large distribution facility. It says that the investment is going to cost $9 million, so that's going to be our cash outflow, and has a 6-year useful life with no salvage value. It says because of rising utility costs, the company expects the yearly utility savings to increase over time as follows. Again, that's in this icon. I've already clicked this data table so we can look at it. Notice that these are unequal, right? These are uneven savings. So generally when we're doing the payback period, that's the first part of this, the payback period, usually all you have to do is to take your investment and divide by your annual savings, but we can't do that in this case because they are unequal. So what we do here is we have to keep track of our cumulative savings until we recoup that initial investment, which again, we're trying to get past that $9 million. That's our investment. So again, after year 1, here's how you do the payback period under unequal cash flows. So year 1, we've just got back $1,300,000. I'm going to write that right there. We go in the next year, you keep on adding. So we got the $1,300,000. We just saved another $1.5 million. So that gives us $2,800,000. That's our cumulative savings up to year 2. So at this point, we've gotten back $2.8 million of our money. So we have to keep going. So we go into year 3. You take the $2.8 million, you add that to the $2,400,000. That's going to give you right at $5,200,000. Okay, keep going. Go to the next year, add the $3.1 million. That gives you the $8,300,000. So that again is year 4. And then now we get to year 5. Notice we're going to get past the $9 million. So we're at $8.3 million right now in terms of savings. We get to year 5. We know we're going to get back our investment sometime during this year. So what you do at this point is you take the $9 million, you subtract out the $8.3 million. So we know right now we have $700,000 left to recover. You divide that by your cash flows from year 5, which is $4,300,000. And that gives you right around a fraction of the year, which is right around 0.16. So you basically say for your payback, it's going to take you 1, 2, 3, 4 full years, plus this fraction of the next year, which is 0.16. So 4 plus 0.16, that's going to be our payback period in terms of this problem. This is how you calculate this for unequal savings. So that's the first part. Now, on the second part, they want you to do the accounting rate of return. So this is a little bit different. So on this one, what you do is you look at your annual cash flows for the 6 years. If you were to add these all together, you're going to get $18 million. So the way you do an average. You basically take, once you add these together, you take the 18 million and you simply divide that by 6. So basically your average cash flows is right around $3 million per year, even though that's not the same amount. That's an average. That's a simple average by just dividing that by 6. So to do the ARR, you also need to know your depreciation. So your depreciation is your investment cost, which is 9 million. Divide that by 6 years. And so when you do that, that's going to give you an annual depreciation expense, an average of right around 1.5 million. So the way you can calculate your ARR is to take your average cash flows, which is $3 million. I just showed you how to calculate that average. You subtract out your annual depreciation, which is $1,500,000, and then you divide that by your investment, which in this case is $9 million. So if you were to do that, that's going to give you right around 16.67% return. So if you look at their answer again, The way you get the number you want to plug in here, it's your 3 million minus 1.5 million is 1.5 million average income from or cash from your asset. Again, dividing that by your initial investment of 9 million, that's how you get this rate of return, which is 16.67%. And then of course the last part you just have to plug in. It says the payback period is, so the requirements were you had to get the payback before 5 years, and 4.16 met that, so that's good. And the ARR is greater than 10%. We got 16.67%. So the final answer is they should at least consider this more in terms of investing in this solar panel.